Jai Hind everyone, welcome to another video. From the last 2-3 classes, we already understood about the lenses and the mirrors. Yes, they are spherical type of mirrors and the lenses. One, the light ray will bounce back, and from second one, the light will go through it. Yes, these are the specific difference between the lenses and the mirrors. Okay. Now, today we will cover two topics. That is, first is the magnifying lens, yes, which is the use of converging lens, and second is the dispersion of white light. Okay, so one by one we will explore it. Before that, I just want to give you introduction of the magnifying lens. It is a converging type of lens where we use the convex lens actually. Okay, in the dispersion of white light, it's a very simple topic where the single phenomena will happen that when the light ray, which you can say the white light, will pass through a prism or any triangular glass slab, you can say, so it will split into 7 colors, and these 7 colors what you have seen in the rainbow. Okay, now we have to see by the animation one by one. Let's see.
So start with magnifying lens. Yes, I know you already have seen or you must have seen that in your daily life around you, astrologers use this kind of material, what is given here in the figure, in the image. Yes, to see our palms, the lines they will see, and tell us about the future. Yeah, and sometimes we see that the archaeological survey they do research on something that very you can say very minute particles are there to find to zoom in they are using this magnifying lens. Yes, and to read also the minute letters and particles we also have used the magnifying lens. Now we have to think about that what is the logic and concept behind this magnifying lens. Yes, students, now we will elaborate that what is the logic behind it. So the thing is what? The magnifying lens is made by the glass, and this is the lens is actually a convex lens. Yes, convex lens, you know how type of properties have? Yes, it have converging type of property. That means after incident on the lens, the light rays will converge at a fixed point since it is coming from the long distance or you can say infinity. Yes. So for the magnifying lens, we have to see that what is the actual reason. Now we just make it side and take another figure for it. Okay. Now you can see the convex lens here, the actual figure of it. Now you can obviously understood that this kind of lens will converge the light ray when the light ray coming from infinity. They meet at fixed point. So this magnifying lens we can use to burn any light paper. Yes, any paper, you can say a piece of paper in the presence of sunlight, if we make a contact between the paper and sunlight, and between that we can place the magnifying lens, so obviously the light ray will converge and more heat will generate. Due to excessive heat, the flame will glowing, and that is only due to because we know already the light have energy, we can say it is a source of energy. So when it will converge on a fixed point, so obviously after some time the energy will convert into heat, and that heat will responsible for the flame. Yes, so that is the logic behind it. Now we can use it to enlarge the objects. Yes, but how? We have to see. In the given figure, you can see this is the last case of convex lens. Yes, when the object is very near to the lens, you can say the case is between the focus and the optical center. The midpoint of the lens is called optical center, and this F denotes the focus. Yes. So, when any object placed between these 2 points, focus and optical center, the light rays actually diverge. You can see the red lines. Yeah. These red lines are actually diverge, and we already know that real image cannot be formed by the diverging type of rays. So, these rays we take virtually in front of the lens. You can say eye here, small eye. Yeah, it is given here. So this is the eye image is taken out where the light rays actually meet, but they meet actually but as a virtual. We cannot see any image in front of the lens because light should go through it. Okay, so that's why if we take any rays in front of the lens, so obviously it should be the virtual one. We just considered it that it can go like that, but it will not go. That's why the image it will be virtual, and here you can see it will be the enlarge. So when the magnifying lens, this kind of lens, we can take to the letters which is written on the copy, and when it is very near to the magnifying lens and slightly weaken up it, so we can see a enlarged image of the letter, and that is the logic behind it. Yes, so this is the use of magnifying lens and the concept behind it. Thank you.
Now we will start with dispersion of white light. Here you can see a structure. Okay, this is a prism. Prism is made by glass, and here you can see the several kind of pages. Yes, this page, and obviously it will be either side also because it's a transparent glass slab. Okay, now first of all we need to understand which kind of shape it page consists. Okay, so here we can see that this particular page is a triangular shape and here is a rectangular shape. So first elaborate how many pages are rectangular and how many pages are triangular. Okay, now first of all see this side. This is the triangular shape because this area bounded by 3 sides, so it will obviously in the either side also. So here triangular will 2. Okay, now the rectangular shape in this kind of, okay, area bounded by 4 side, so it will be in the other side also. And the downside, the base is also, you know, there is a rectangular type of shape, so obviously 1, 2 and the base 3. So here rectangular is 3, total 5 pages. Okay, so prism is a glass slab type structure which made by 5 pages. Out of them the rectangular shape is 3 and the triangular shape is 2. Clear? Okay, now we have to elaborate that what will happen through the prism, so it will start dispersion. Okay, since white light we know it is not a single color, it is not made by single color. White light is composed of several colors and they are 7. Yes, the colors of rainbow, you remember na? I know this is a VIBGYOR, VIBGYOR. Okay, so we can state that V stand for violet, I stand for indigo, B stand for blue, G for green, Y for yellow, O for orange and R for red, and all they are 7. Got that? So when the white light will split into this kind of 7 colors, we can say it is a dispersion of white light. Here again we take a triangular glass slab. Actually this is the phase where we make the base, actually it will be the rectangular, so upper side will be the triangular one. So we take triangular shape. Now when the white light is passed through it, obviously it will start bending, because you know when the light ray will enters into a denser medium like a glass slab, so obviously it will start bending towards the normal. Okay, so due to this triangular shape, it will split into 7 colors. Okay, 7 colors like that. Okay, these 7 colors are actually this Vibgyor. So now which color will come forward? Okay, so it is clear to you that what is the dispersion of white light. So we can say, okay, when the white light, okay, pass through a triangular glass slab, it will split into 7 colors. So this phenomena is known as dispersion of white light. Now in the second slide we can understand that color, since already we know the white light is not a single color, it is made of mixture of 7 colors, and these 7 colors are Vibgyor. Okay, yes. Now in the figure you can see clearly that when the white light passes through a prism, due to this triangular shape, it will start to splitting in 7 colors. Got that? Yeah. So here we can conclude that what is dispersion of light. So start exploring. The splitting of white light into 7 constitute colors on passing through a transparent medium like glass prism is called dispersion of light. I think you all have understood about that. Okay. Now we will take an example. Here example of a Newton disk. Okay, Newton disk about, it is a circular type of disk which have 7 colors, the same 7 colors. Now when we start rotating it with a faster view, what we'll see, we see that all 7 color mix together virtually, and it will seems to be a white light. It will not start converting into white light. I know that it is very difficult to see that available for a white light, it will not happen, but still you can see the all colors are mixing together, and nearby it can show that it is a white light. So here we can conclude that Newton disk, also known as disappearing color disk, is a well-known physics experiment with a rotating disk with segments in different color appearing as white when it spins very fast. Got that? Thank you. But here we have to know that which color will come fast. Do this. In this we can see that in the rectangular glass slab the red one is come faster. Okay, why? Because the velocity of the red light is faster. Okay, that's why, because the wavelength of the red light is very high. That's why we can say first of all will red light comes up and then the least violet. So according to the velocity, the Vib G Y O R. Okay, so the red have the fastest, okay, and V will be the least, and they are the mediator. So R is the fastest color. That's why in the red signals we already have seen we use the red colors to the stopping the vehicles. Okay, and you can say the signal of danger is also used as the red. Okay, and the velocity of the violet is least. That's why when the light will start bending, first of all red will exhibit, and then yellow, orange, and then yellow, and then green, and then blue, and then indigo, and the last is violet. Here you can see clearly. Okay, in this figure it is very clear to all of you which color come first is red
and then all colors, and last is wave cure. Okay, thank you.
I hope all you have understood about the magnifying lens and the dispersion of white light. Please go through the book, what is the PDF form given in the WhatsApp group, tally with it and see the video very carefully and tally with it. Thank you and Jai Hind.